Good morning. A lot of people. Should be exciting. Okay, we're going to talk about Conway's Law in different areas. Space and ontology. Ontology is a really nice big word that everybody uses and nobody understands, nobody defines. But that's what we're going to talk about. And I'm hoping to leave some time at the end for questions and answers. So if I manage to provoke you, or annoy you, or intrigue you, you should have an opportunity to raise those questions, and we can talk about them a little bit. So Conway's Law, everybody has heard of it. Most people kind of misuse it a little bit or misdefine it a little bit. The original law was that the communication structure among members of a team would shape the communication structure among the elements or modules of a software program, so that you had this kind of mirror image between the way that the people talked and the way that the software talked with each other. It got generalized, so the organizational structure of your team would be reflected in the organizational structure of the program. And the idea expressed in Conway's Law has been empirically confirmed. People at MIT, people at Harvard Business School have published results saying, yeah, the mirror image is there, and they interpret it in still a different way. That it was the modularity of the team would be reflected in the modularity of the software. But this idea that you have this very close correlation between the way groups of people are organized in order to produce a software will be reflected in the software. And we're going to talk about space and, well, an example first. If your organizational structure looks like this, your software is going to look like this. Top-down hierarchical control. This is a program structure chart, in case none of you have ever seen one before. It's a technology that dates back to the 1960s, when we first started doing software development. And it continues to be the default architecture of every single program that most of you write, especially if you write in a language like Java, where you have to always have a main routine. That's the reflection of this kind of top-down hierarchical control, which is the way most businesses are still organized. I chose the Department of Defense on purpose. They're one of the most bureaucratic, hidebound organizations in the U.S. government. So we're going to talk about space, and we're going to talk about ontology, beginning with space. And I'm going to tell you a story first about space and the way software is developed. So Cray used to be the world's fastest computer, and Cray Research Corporation built these things, and they dominated the market for a long time, as long as there was this notion of a single supercomputer. When you started to get to clustering computing, they lost their way and disappeared from the planet. But when they first started business, they had a number of engineers. They built this really cool supercomputer, and they sold it to Los Alamos National Laboratories in New Mexico to do atomic blast research, simulation, and modeling. They sold it to Los Alamos National Laboratories in March, and they had to deliver it July 1st. Inconvenient problem is they didn't have an operating system. So they had the hardware, but they didn't have an operating system, and the customer kind of wanted one. So Seymour Cray and Chen and the third person, I don't remember who was working there at the time, sat down towards the end of March and said, okay, we've got to write an operating system in 3 months so that we can deliver it with the computer to Los Alamos. At the time, they were in Chippewa Falls, Wisconsin, and they had a small little office. And the office had one separate private office for each of the three gentlemen that were writing the operating system, and then a big common area where they had a coffee machine, popcorn machine, a lunch table, the various accoutrements of a lunchroom. The men would come to work in the morning. It was three guys. So the men would come to work in the morning. They would have coffee. They would talk about what they were going to do today. They would talk about a little bit about what they did yesterday and what was giving them trouble, what they had to think really hard about today. So a classic stand-up meeting, right? Probably took them however long it takes to brew a pot of coffee and pour 3 cups. They retreated to their cubicles, wrote code furiously all day long. Come out for coffee break, come out for lunch, come out for afternoon coffee break, come out at 5 o'clock or whenever it was they decided to go home, and again repeat this kind of conversation amongst themselves. And they were able to complete the operating system, build it, deliver it, and it worked just fine. And this became a legend in the company. And it became so much of a legend that as they expanded and grew and decided they had to build a big campus over in South St. Paul, South Minneapolis, they kept this story, this myth of how their first operating system got written and how the space contributed to that. So when they moved to their big, huge new campus, they had 4 floors on the campus, 2 wings, so you got 8 floors. But on each floor, they recapitulated Chippewa Falls. They cheated a little bit. They put more than 3 offices around each of the common areas. They did have some economy of scale, after all, that they had to deal with. But they replicated this space, and each common room also had its own administrative assistant who had a desk in that common area. But the big thing was that you would have this replication of the Cray office space, and they thought that that would make it possible to replicate that success with the software. That the teams working in this campus would be just as successful at bringing out new iterations of operating systems, new operating systems for the new versions of the hardware. And surprise, it didn't work. It worked really well locally, but in the campus as a whole, you had people that were building mass memory software, or software to handle the mass memory kind of thing. You had software over in a wing on the other side of the building that was doing the bus architecture. You had somebody on the second floor on this wing that was doing the CPU optimization. And all of these people weren't coordinated. They didn't have a common area. So obviously they started going in their separate different ways. So the space had a definite effect on what it was that they were able to do. And what happened, of course, is that the people over here working on memory and the people over here working on core memory or CPU kinds of activities would be having problems with the operating system as a whole, and they would then try and rewrite the core part of the operating system to suit their specific kinds of needs. So you had people in different wings working on the exact same part of the operating system at the same time without talking to each other. That's one of the things that contributed to Cray's demise, plus the fact that there were faster ways to do hardware. So, but the myth of space affecting work, was something that had appeared at Cray, and they were the first company that I know of that self-consciously tried to shape space in order to facilitate or to optimize the kind of software that people would produce in that space. recognize this kind of a workspace? This is our legacy workspace. Escaped it as fast as we could in most cases, but it's still fairly prevalent out there. You're pretty much guaranteed that your software is going to have all these kinds of interesting silos because there is minimal communication structure between teams that are stuck in, or team members that are stuck in cubicles. This is the default production, or the default space for where software is done. You may not recognize it, but this is, in fact, the way that space in most places is still organized, and most work is still organized, and most teams are still organized. And it has to do with production. The notion that software development is a production process, subject or amenable to project management, is something that has been around since 1951 when they built the very first business computer. It's endemic. Cannot seem to escape it. So even when we say, oh, we're going to be agile, and our agile method includes all these little iterative loops and so on, when you look at the overall production of a piece of software, it's still a production process, just as much as it is in a factory. So that's why I say that that factory floor is the default process. Been attempts to move away from this. Let's have an open office. How many of you work in an office, open office, and how many of you enjoy working in an open office? So the chuckles I take mean, yeah. An open office, the way that it's potentially conceived or is usually conceived, gives a different kind of a space, but it doesn't change anything in terms of the team organization or the work organization. So here we have a space in conflict with the other aspects of Conway's Law, like the work organization. And the biggest aspect of that is that even though we are in a shared space and we define ourselves as some kind of a we or some kind of a team, the work is still my work. And so if I'm trying to do my work in this busy environment, it really gets annoying in a hurry, which is why time after time, study after study, it's proven that this kind of open workspace is not effective. It's not useful. It impedes the development of the work. And it's not the space per se, as we'll see in a minute. It is the conflict between communication structures, organizational structures, and the space that is intended to support them in some fashion or another. I don't know if anybody still does pair programming much anymore. Anybody still do pair programming? So this is an open space only for pair programming. This kind of arrangement and the physical juxtaposition of two programmers with a single terminal and a keyboard is a spatial arrangement that really enhances local quality of your software. Doesn't do a whole lot for overall gestalt quality of your software, again, because you're still working in this notion of a production process and things are still going down the assembly line. If you are in a really good pair programming environment, you're constantly switching pairs, so in theory, you get this gestalt view of the software. But in point of fact, you end up just doing a lot of context switching. And it ends up not making the process as good as it could be. And in part, again, it's a mismatch between the physical structure and the organizational structure and the work structure. So the predictable outcomes, you get, you have modularity, but it's modularity that's kind of in silos. The communication between these modules and the links between them has a tendency to be, it went blank for a minute, has a tendency to be minimal. So what you end up getting is you get a lot of maximal coupling. Any of you remember how many different kinds of coupling there are? Shout out a number. There are 7 different kinds of coupling, from pathological to message coupling. But you end up with a lot of this pathological, or things towards the pathological end of the coupling spectrum. And the cohesion of your modules ends up being cohesion, is what's called logical cohesion, that is cohesion, the things are together simply because that team is together. There's no rationality across the program. Project manager is doomed, and they're going to take it out on you. Or they are going to skip town before, the week before the project is due to be delivered. And there's no global integrated view until the last days, and that pun is very much intended because for most software projects, there is a last days, the end of the world, when the project fails. And I still say that for most of them. Everybody in this room is accepted. None of you have ever had a program fail or a software system fail, but you're the exception. The industry as a whole has a big problem with this. An example of the maximal coupling kind of effect that goes on, or that you see in software that's developed in these production-centric kind of spaces. So how many of you remember when LeftPad broke the internet for like 2 days? And why? Because nobody knew that their software was pathologically coupled to 7 or 8 layers down into an open source library that ticked off the owner or the author of LeftPad, so he tried to remove it from that library and broke the internet. That's, even when we think we are being really well layered, really well modularized, we still end up with this kind of maximal pathological coupling. So if you change the workspace, would it make any difference to the work product or to the work process? Can you imagine working here and doing your software development here? One of the things that we really are not skilled at as technical developers is communication with the users, familiarity with subject matter outside of our narrow discipline of how to write Java code really well. If you're in a library, you are at least tempted to go and read a book once in a while, other than a programming text. This is a question I have to ask every audience that I confront, particularly in this business. How many of you read a business book in the last year? Oh, surprising number. How many of you subscribe to a business magazine like Fast Company? 1, 2, 3, okay, a handful. How many of you read a book on the history of computing, like the book about the Leo? How many of you ever heard of the Leo, by the way, which is 1951. It was the world's first business computer. Had order entry and payroll and even an expert system to blend tea leaves. I get a lot of puzzled looks and I don't see that many hands. As a profession, we are abysmally ignorant of our own history, so we keep reinventing it. How many of you read a good mystery novel? A lot more. I'm surprised. This is a really literate audience today. I'm getting a very abnormal response to these questions. I'm proud of you. But if you're in this kind of a library, that's very useful. And reading these other kinds of books and other kinds of disciplines are extremely valuable if you want to have insights into how we're going to build our software, if you want to have insights into how our businesses are operating, if you want to go out and find those bounded contexts and those core contexts and subdomains and domains. You're going to get all of your inspiration from things outside of programming text. It would be really, really noisy if we populated every one of those desks with a developer. But the library would keep it a little bit quiet. But Other than that, it's an interesting space, and you would probably get much better integrated software and much more inspired software. If you want to have the optimal space, if you want to have the very best software that you can develop, then you need an optimal space. So the space that is optimal for the development of software is this kind of space. There are users in that space, there are domain experts in that space, there are developers in that space, there are people that have skills besides coding in that space, there are coding people in that space. This is actually a design space. The people in the design community have been figuring out how to work in teams and come up with really interesting, innovative, effective products, or design outcomes for a long, long time. The business community is also jumping on this particular bandwagon. We saw a really cool bandwagon in the keynote this morning. Design thinking is kind of a similar sort of thing in some regards. But the businesses have also been trying to reorganize their workspace, their business space, where they do what they do into this kind of a fashion. They have been talking about autonomous self-directing teams for 30 years. We've been talking about it for 20 years since the invention of Agile. Not that every business does things this way, but at least they're talking about it, and there are a lot more of them that are actually literally doing things this way. What happens in this kind of environment is that the work pulls in those people that are most essential to getting the work done. So this is kind of a work-driven environment and context. It's an environment where the work writes itself or creates itself or establishes itself by saying, hey, I'm a program over here, I really need some kind of an interface so that I can communicate with my humans. And then it draws in the people that can draw that interface. What you're likely to get in that kind of a space is you're going to get software that first and foremost is outward looking. So in spending all day sitting and trying to build this conceptual construct of what's going on inside of the machine and how the software is operating and how the software is working, which Fred Brooks years ago said was the essential problem of software development. Instead of doing that, your work is going to be focused outward towards the customer, the client, the domain in which you are going to deploy that software, and your attention shifts from the technical details of how it works to why it's doing what it's doing and what it is that it has to do. And it creates a very different kind of a framework for thinking about even the most technical of details. So you're going to be focused on business value. You're going to have minimal or minimized, I guess, concerns about establishing arbitrary correctness of your software. When you're focused inside the computer, you are bent on a task of trying to recreate, replicate, simulate in some fashion this complex system out here, which is the real world. And that's a really, really hard task. And you create all these kinds of weird frameworks and weird structures and weird programming languages to try and facilitate how you're thinking over here. And when you do that, then you have to set arbitrary standards for whether or not you're conforming to these kinds of internal models, which means you have to have lots and lots and lots of testing. If your focus is outward, your software is going to end up being much simpler and designed more efficiently and more effectively, and then the code you have to write is going to be equally simplified. One of the really biggest things is it's going to start shifting away from this my work-centric thing that we've inherited from the beginning, that I go into a job or into a project and I have a very defined role and I have a very well-defined set of work, and I am monitored and evaluated and compensated based on what I do. The idea of our work, teamwork, things of that sort are really hard barriers to overcome. But this kind of a space will facilitate that. It also creates creativity, primarily because you've got this polylingual, not necessarily a natural language like French, English, German, Italian, Russian, but in terms of design thinking, anthropological thinking, coding, process management to the extent that that's useful in these kinds of situations. Moving to ontology, we can start with this misunderstood term. Ontology is really ultimately a sense of metaphysics, or a subset of metaphysics, or closely associated with metaphysics. How do we know what is real? And how do we know that unicorns, for instance, are not real? Usually we make distinctions about what is real and what is not real is based upon the things that we give names to. So even though we give a name to a unicorn, everybody kind of knows that it is real only in terms of an imaginative sense. We can write really cool fairy stories or princess bride stories with unicorns in them, and it's an effective means of communication, but it doesn't have metaphysical reality. But it does have conceptual reality, and it does affect the way that we talk about things. So what's the 2018 definition of a unicorn? Anybody want to jump right in and tell me what the... Actually, it's about 15 through 20. Go ahead. Yeah. So unicorns are used all the time for these startup companies that have billion-dollar evaluations and zero earnings, zero customers, whatever. But somebody thinks it's really going to make money someday, so they throw investment at it, and then they call it a unicorn just in case it goes bust. But translating, different groups have different ontologies. Different cultures have different ontologies that are built into the language of that culture, or the language that culture uses. Subcultures have different languages. And translating between these two things is oftentimes very difficult. In our case, the biggest translation that has to occur is between the business ontology and the development ontology. What we talk about and say and what we acknowledge as being real inside the computer and what the business acknowledges as being real outside the computer in the domain. The Worf-Sapir hypothesis is a foundation way of thinking about this. This is a very controversial kind of a hypothesis or notion, but it has some very real substance to it. So Benjamin Lee Worf was an amateur anthropologist, amateur linguist. Edward Sapir was a professional linguist, an academic linguist, wrote lots of books on language. The Lee-Worf, Sapir-Whorf hypothesis is usually characterized as language determines your thought. That if your language doesn't have a term for something, then you can't think that thing. One of the famous examples that was used by people who have this interpretation of the hypothesis is that in Hopi, there's no way in the language, there's no language construct for expressing simultaneity. So they can't ask a question, where were you when the Twin Towers came down? Or what were you doing at the same time that the Twin Towers came down? You can't ask that question, and therefore you can't answer it in the Hopi language, supposedly. You can say, well, when I heard that the Twin Towers went down, I was doing X. But they have this very relativistic notion built into the language that would make Einstein very happy, but makes it difficult to express simultaneity. But what Sapir-Whorf really said was that language shapes or constrains culture. So they never said that you couldn't speak Hopi and end up finding some kind of paragraph, perhaps, to convey or express this idea of simultaneity. They just said you couldn't do it in a syntactical single sentence. But there are these constraints, and these constraints are very real. We have very definite inability to talk to each other in a common language across professional silos. So there have been attempts to address this translation kind of an issue. One of the first was objects and object-oriented programming. The unstated ideal of object-oriented programming was to establish a common language between the business domain and the implementation domain. But that in turn was based upon an earlier premise of let's create a common language between the way that children think about and talk about their world and what the computer does in response. So Smalltalk was invented as a dialogue language, not a programming language, but a language by which children and relatively naive adults could talk to the computer, could interact with it in a conversational style. It worked really, really well. And people were able to build really, really cool things based on this approach, this conversational approach to kinds of things. But then it went commercial, and everybody ruined it. It became a programming language, and therefore had to address all of these other kinds of constraints of any other programming language. And they very literally killed the language about 10 years before Java came along and finished the job. And the reason being is that this is what was supposed to happen, is that an account in the real world would have the same cognitive invocations or evocations as an account in the implementation space. So this is supposed to be a common language. What went wrong in first part, or in major part, was that an account in a business domain is a bundle of behavior. An account does things. It provides services to the bank and to the banking customer. And it is talked to, or it is addressed, or it is thought of that way as an entity, even an anthropomorphized entity, projecting human qualities on it. So people talk about inanimate objects in the domain all the time as if they were people. Same kind of thing with an account. My account was overdrawn. I wasn't overdrawn. My account was overdrawn. But when we implemented this, we implemented it as a data entity, a thing with attributes that can be normalized, the distribution of the values in those attributes, all these different kinds of things. This is really annoying. So we had this mismatch between what the words said in the domain and what the words said in the implementation space. And what's worse is that we never bothered to converse or talk with the domain expert enough to expose this kind of difference. We just went and got a bunch of words from the domain expert. We went back to our cubicles or our production space, and we immediately started talking amongst ourselves in our own language and making these mistranslations and misinterpretations. The notion of a shared model, which comes from domain-driven design, which is why you're all here today. Your program source code is a model. Guarantee you it's a model. Is your source code shareable with your domain experts? Should it be? Come on, take a stand. Yes, it should be. which means that you really need to rethink what language you're programming in. There isn't very many domain experts in the world that are going to really enjoy reading your Java program, your C program. They might do a little bit better with your Python program or your JavaScript program, depending upon how clever you are, of course. And all of you are very clever. You have a knack for making your code unreadable, even to domain experts or to implementation experts. But it should be. That's again, I'm not saying everybody should run out and use Smalltalk, but I am saying that if you want an exemplar of a language that is a common model and shareable between the domain and the implementation space, Smalltalk is an exemplar of such a language. It has its own problems and everything else as a programming language, but as a common shared model, it is at present unsurpassed in terms of a language. So you should be able to share these things. So we have this term that is very common in Agile, and I don't think anybody here is unfamiliar with the idea. The project backlog, a product backlog, a sprint backlog. This is a collection of stories that are sitting out there. But what exactly is it? What is the meaning of a backlog of that sort? It's a project management tool. It's a way of saying, oh, this is the work that needs to be done, this is the work that is being done, this is the work that is finished, and I can sit and project and plan and identify what work is going to be done in what sequence, in what order, and I can report whether or not I am on track as a project manager. I can walk into the room and look at your burn down charts or your burn up charts or all the other kinds of things, your storyboard, assuming that any of you have these things in your workspace. And do my job as a project manager just by monitoring these shared spaces. So is that what a backlog is for? Is that the meaning of it? Is that the reason that it existed? Or the reason that it was proposed? Is it an inventory? So most people here are at least familiar with lean software development based on the Toyota production process. And lean software development is very much consistent with the Toyota production process, even though it has an element of two from the project design, the Toyota project design process. Almost all of it is focused on production and production models. And in the lean production model, this kind of an inventory is waste and should be eliminated. Should have no place. You shouldn't need these kinds of inventories. Now, what they do in exchange is not spelled out, but it shouldn't be there. But when these backlogs were first proposed, and the intent of these kinds of backlogs was to be an evocation device for your theory. So the alternative to production model of software development, another kind of model that was advocated is by Peter Nauer back in the 80s, is that what we are doing when we are developing software is we are building a theory, a consensual theory of an affair of the world, of something in the domain, and how we're going to write software to support or handle that domain issue or that domain problem. And we're building this consensual theory by exchanging stories, by doing all kinds of other activities, modeling, exploring, developing, and using the software to give us feedback into this theory about whether we've got it right or wrong or anything of this sort. And stories, as first advocated by Kent Beck in Extreme Programming, were an invitation to a conversation in the future and a reminder of conversations past. It was supposed to be an evocative tool that you could tell stories among yourselves, you could tell stories with the users the clients, the domain experts, and you could capture these stories in a 3x5 card, put it up here on the wall, and then whenever you were doing work, even if you were doing work on this particular story, you could glance up at the wall and you could see the context for that story. You could see what the state of your theory was. You could see, well, we don't really understand what's going on over here, but that's because we haven't worked on those stories yet. So when I look up at the board and I see those particular stories, I don't have anything coming back into memory because we haven't talked about it yet. But once you have worked through these stories and you start to develop that really good, strong, complete theory, you look at a card, it emotionally brings back to memory not only the specific conversation about that specific card, but all of the other cards that you've talked about. So it's like when you walk down the street past a bakery and you smell cinnamon, you don't just see grandma's cinnamon roll, you see grandma in the kitchen with the dusty flour on the table and the cinnamon rolls. Some of them are in the oven, some of them are rising over here on the shelf. You can probably remember the conversation you had with your grandmother in that kitchen from one little evocative trigger. And that's the way that stories are supposed to work. And so a story backlog is not a backlog at all. It's not anything of the sort. It is the state of our collective theory in the form of evocative triggers. How many of you work on teams with coaches? Okay, people are shy, but I didn't see that many hands. How many of you work on teams with scrum masters? Is there a difference? Is there a semantic, meaningful difference between a coach and a scrum master? You're shaking your head no. How many people agree with him? How many are just totally undecided? How many of you just refuse to raise your hands? There's a very significant difference in the way these roles are defined, the way these roles are played out, the way that people in these roles see themselves and see what their activities are. So the word that you use to describe this person that interacts with the team makes a huge difference. Won't go into detail, but there is a big, big difference between coaches and scrum masters. And it affects the way that you write your software. A scrum master is going to enforce the production process model of software development. A coach can be much more of a facilitator of this theory building sort of thing, in part by protecting or insulating the team from the rest of the organization and providing the resources so they can sit and quietly think about what it is that they're doing and get things done. You can go this language. Issues can go all the way down to really fairly technical kinds of things, like writing your code. So when you're writing code and you have this situation arise where you have to do repetitive things for a certain number of times, do you iterate or do you loop? If you are using collections and saying collection do this or collection select that, you are iterating. You have no conscious awareness of how the iteration is mechanically done. You're just saying, hey, do this, and the collection knows how to iterate across itself, which is basically a loop, but the collection iterates. In most cases, you're going to do loops. And guess what problem arises when you try and write a loop? You get an off by one error. You do a do while and a do or a do until, and you either do one too many or one too few. So you're always off by one in the number of times you go through the loop. Is this a common error? None of you make this error? None of you make this error if you are reusing code. But empirical studies have been done of programmers, And if you have a white piece of paper in front of you and you have to write a loop, your odds of getting the loop, the right loop, and avoiding the off by one error, 50-50. And it doesn't matter whether you're a beginning programmer or a 10-year experienced programmer. If you have to sit down with a blank sheet of paper and write a loop, you've got a 50-50 chance of getting it right. And this is empirically demonstrated. People have studied programmers and counted errors. Typing is another kind of an error. Type mismatch errors are another thing that has showed up. And empirically, a type mismatch error is far less prevalent than a casting error. Casting errors have about 2 to 1 over just making a mismatched type. So it goes all the way down to this very kind of technical level. So your language that you use matters. It constrains how you think about things. A lot of times this language is implicit. So none of you go to work on Monday, even if you're a Scrum Master. Nobody goes to work on Monday and says, hey, we're going to work on our production process today. But underneath the covers, that's the way you're thinking, and so that's the way you behave. That's the kind of things that you put in place. That's the kind of accountability that you put into place for yourself, your team, the project, all those different kinds of things. This one, none of you have ever thought about that, which is why you didn't admit to making the error. But it's ingrained. You watch people doing a programming language, even one that has strong collections like Smalltalk, which I used to teach for 10 years. People would write Smalltalk programs and they would constantly put in explicit loops. Because that's just the way that they thought the software was done, because other programming languages gave them that construct, and unfortunately, so did Smalltalk. So it didn't ever occur to them to go and look at collection behavior and see how they could do things like a do or a select or something of that sort. So language matters. Your ontology matters. You are going to leave this room today, and except for about 40% of you, 45% of you, you're going to continue to have problems communicating with your domain experts. Part of that, of course, is the fact that you never get to see one. You might get to see a product owner or an architect or somebody like that, but those fuzzy creatures over there called clients or users, you very seldom get a chance to talk to them. So see if you can make things different. So that concludes things. I have to advertise. The Design Thinking book is going to be on sale tomorrow, a few copies of it, if anybody is interested in that. And the Object Guild is an organization that I'm trying to start with my colleague Jonathan here in Amsterdam, where we're going to apply a lot of these kinds of ideas that I talked about yesterday in my workshop and that I am bringing up today. So we have 10 minutes left for some questions.
I have a speaker box for people that want to ask questions. Where shall I throw to? Okay, this should be fun.
Hi. So early on, could you maybe explain a little bit more about the difference between an open office and a creative office?
Open office was, they just says, we're just going to put people together in a space and assume that because they're in the same space and they can't hide from each other, that they're automatically going to start talking to each other. And that this conversation is going to result in better integration of the different aspects of our code base. It's going to result in creativity because people are going to pop up and say, hey, I have this interesting idea, or here's a metaphor that we haven't thought about before that we might be able to apply to our software. That's an assumption. And of course, it didn't happen. And it didn't happen because none of the people in that room have ever been trained to work in a team. So if you think back on all of your training, you think back on university, how many times did you were oftentimes forced to work in teams, but how many times were you evaluated as a team? How many of your GPAs were collective in that area? How many times did you go into a class where you had to work in a team and the instructor told you 5 things about effective teamwork, or 5 things about interpersonal relationships, or 5 things about metaphor and why you use metaphor to explore some kind of a development space? You had none of that. So the assumptions didn't hold. So it just became a cacophony of individuals trying to do individual work in a noisy, loud environment. You go to the artistic, the design open space, and those people are defined, or are taught different kinds of teams. They're defined a whole bunch of different kinds of team roles. So you go into a creative space and you might find someone who is playing the role of an anthropologist. This is the person who's going out and looking at the client, the domain, and figuring out how things really do work in that domain, so that you have an informed decision to use over here. They might have someone who is a tool maker, someone who can very rapidly craft prototypes, out of cardboard and pasteboard and things of this sort. You might have someone who is really good at looking at a problem and an obstacle in the code and then making some kind of imaginative leap around or over or past that code so that you can get going again. And then once you get going again, you can go back and rationalize the snag in a way that's solved. So they have a lot of different kinds of roles. Tim Brown, who is founder of IDEO, who is one of the leading design companies that is advising your business clients how to apply design thinking to their business, he calls them the 10 Faces of Innovation. But these are 10 roles that exist within a design team that we don't have any equivalent of in a software development team. But they're trained in this kind of stuff, so they know how to work together as a team. And they know how to take advantage of the space, which in an open office you don't. You're always looking for a place to hide.
So one of the points you brought up was about how, the overfocus on the production aspect, that we're it's practically part of the zeitgeist. We just believe everything should be like that. Would you have any advice on how to combat that? Because it seems like when an ideology like, say, Agile or Lean is brought in, it's inevitably forced into that shape, which ends up destroying a lot of the value. Would you have anything to help that process, help stop that happening?
Yes, 2 things. So one of them is that you go and read Peter Nauer's paper on software development as theory building and understand that paper. Alistair Coburn put a copy of that paper in his book on agile software development, agile methods, and he says it's integral to the way that he defined crystal clear, for instance. So you can find roots to Peter Nauer in the early agile movement. You can't recently, but that's where I would start, either by going and getting Alistair's book, which has the essay in it, or just going out on the internet and finding the paper directly and understand it. The second thing is to take really seriously and get management to let you alone, hire a coach to protect you from management, and take this self-organizing, self-directed team metaphor really seriously. Now that comes with a consequence. If you are going to be this self-directing, self-managed team, and you're going to get management off your back, you have to fulfill the promise that Kent Beck made when he first proposed these kinds of agile teams and self-directing team. It is, if you get off my back, Mr. Manager or Ms. Manager or Mrs. Manager or Miss Manager, that's 2 S's, not 1. then I will become the best professional developer I can possibly be. Now that means that you not only have to know how to write code or draw a UML diagram, it means you need to master metaphor, you need to master the history of our profession, you need to master a little bit about the history of science and how it affects technology. You need to be able to answer the question, who invented computational science? I don't hear. It wasn't Leibniz who was usually given credit for it. It was a Majorcan mystic named Ramon Lull. He was a Catholic mystic that lived in Spain in the 1500s, 1600s, something like that. Was the inventor of this. And you should know that. And you should know a bunch of other kinds of things too. The objective in the business side of the house is this notion of a modern polymath. Someone who knows a lot about a lot of things and knows a huge amount about certain kinds of specific things. So those are the two things you need to do. Become a modern polymath, working in a self-directed team under a coach, and read Peter Nauer's book. He's got several books, but read that essay in particular.
Thank you, and I think I'll start with the second one.
One more? Way over yonder?
I've got a question about the science space kind of working. How do you avoid only working on today's problem? Sometimes a problem takes more time, like hours or days, and having all people with different kind of interests in the room, well, in my opinion, it shifts very fast to today's problem, the bug we heard yesterday about, or the complaint we had yesterday about, and not the vision we have in 3 months. We want to have over 100 customers using this new product.
You very literally use the space, the physical space, as the way of coordinating work between people. So the way that you coordinate work across the team is not by direct team member communication. It is by you're doing your work over here, and you may or may not have someone else doing work with you, and you're working on it for several days. But as you're making progress, or as you are advancing your understanding or thinking about your work, you're putting something up in the physical environment so that everybody else just needs to glance up there and say, oh yeah, he's still busy on this, but it looks like he's going in an interesting direction. And that may inspire them to come over and actually help you do something. But you very literally use the physical space. And this too has been present in Agile, more so in the early years than in the moment. But the idea of big visible charts, information radiators, they weren't there just for the project manager or management to walk through the room and see if you're on track. They were there for you to communicate asynchronously with each other. So use the space.
Thank you.
Okay.
Okay, that's all we have time for. Give it up one more time for Mr. Dave West.